Hello everyone, and welcome to this great video on domain and range of functions and relations. But I think before we start, we need a corny math joke. So, how do you make 7 an even number? You take the s out. But shh. Alright, so let's get into it. Domain. Domain is the set of all inputs or x-coordinates. Range is the set of all outputs or y-coordinates. So domain is x, range is y. One way that I like to remember this is with an acronym called ZIDYOR. Sounds funny, ZIDYOR. ZIDYOR stands for x-coordinates, inputs, domain. Your y-coordinates, outputs, range. So ZIDYOR. That might be a fun, interesting, creative way to remember which one is domain and which one is range. So domain is x, range is y. If you need to get the rest of that down, go ahead and pause here. Okay, so here's some examples. Basically, what is the domain and range of these ordered pairs? First thing, it's always good to just make a note. Is it a function or not? So let's look. We've got 0, 3, 2, 9, negative 3, 5, 0, 2, and 1, 1. Is this a function? It is not a function because look, we have an x-coordinate that repeats. So even though this doesn't have a function, we can still identify its domain and range. And again, remember the domain is the set of all of the x values. We're going to use these little curly brackets. And we're just going to list all of my numbers that are my x-coordinates. Always good to write in numerical order if you can. So we've got negative 3, 0, looks like 1 and 2. And I'm not writing that 0 twice. I don't need to in this case. And then our range. Again, we'll use these curly brackets. And we'll just list out our y values in order. Let's see, we've got 1, 2, 3, 5, and 9. Okay, and that's all you have to do to identify the domain and range here. The curly brackets just tell us it's the set of numbers. So it's just the set of numbers that we're listing. Okay, so let's look at B. Is this a function? Well, it sure is a function, because none of our x values repeat. Remember, y values can repeat, but your x values cannot. Okay, so what is the domain? Remember, it's the set of all x values. So we've got negative 2, 0, 1, and 2. And our range, again, is the set of all y values, which in this case are 0, 3, and 4. And again, we're not going to write that 3 twice. Even though it is listed twice, we don't need to write it twice. We just need to write it once. Okay, so that's all you're doing here. Simple enough. Well, let's look at a mapping diagram. Same idea here. So is this a function? Do any of your x values repeat? Well, they do, because negative 2 has 2 outputs. Negative 2 has an output of both 1 and 3. So this is not a function. Okay, well, what's our domain? Our domain is all the x values again. We've got negative 2, 0, 1, and 3. And what about our range? Just the y values. Negative 3, 1, 3, and 4. So all this is just very simple, just identifying which ones are your x and which ones are your y. We've got one more mapping diagram example here. Is this a function? Well, look at 15 here on the x side. We've got 2 outputs for 15, 7 and 9. So no, fortunately not, this is not a function. Okay, so now we'll go ahead and list our domain. Domain is all our x values. Negative 8, negative 1, 0, and 15. And again, that's everything over here on the left-hand side. And our range is everything on the right-hand side, just 7 and 9. Simple enough. One thing I want to introduce to you here with the graphs is interval notation. And when we have interval notation, we use parentheses when it doesn't include a number, and we use brackets when it does include a number. So I'll show you that in just a second. But here I have a graph, and this is really important how you think about domain and range here. So domain is going to go from left to right. That's how we're going to find our domain. We're going to look from left to right. Our range is going to go from the bottom to the top. That's how we'll find our range. All right, so domain here, we're going to write in both inequality and interval notation here. Well, if I look at this graph, I see on the left-hand side, it goes from here, which is 1, all the way over to here, which is 6. So that means all my domain, all of my numbers here for my domain, all my x values fall between here 1 and here 6. Remember how we write that with inequality notation. We could say 1 is less than or equal to x, which is less than or equal to 6, just like when we did the compound inequalities section. And we have to do a separate for our range. And our range is going to go from the bottom, which looks like it's down here, to the top. Now this one's a little harder to see, but it looks like our graph definitely meets at 1 for that range. Okay, so we can say it's going to be at least 1 is less than or equal to x. But one thing that's a little hard to see here is it doesn't quite look like this top part of the graph reaches that 7. So we're just going to use a less than 7 here because it's not quite hitting that 7. And I'll make sure on a quiz or a test to make sure that's obvious and that you can see it. Now interval notation. So remember I said we use brackets to include numbers. So this is how I'd write this in interval notation. Bracket 1, 6, and close the bracket. For my range, well, we said it includes 1, because we have 1 is less than or equal to x, but it doesn't include 7 because x is less than 7. So I'm just going to use a parentheses to close that out. So it's a little bit new, it's something we'll practice, but basically when it includes a number, we use the brackets. When it doesn't, we'll use the parentheses. Okay, let's look at another example. We've got this fun-looking sideways V, and it looks like all of my domain, it looks like it goes on forever to the left, but stops right here at 0. So I'm going to say that my domain is all the numbers that are less than 0, or x is less than 0. My range, however, is a little harder to figure out. It's going on forever. It's going up indefinitely, and it's going down indefinitely. Eventually, it's going to hit infinity. So I can just say that my range is all real numbers. And that just basically means they're all the numbers, from negative infinity all the way to infinity and beyond. So let's write that in interval notation. My domain is everything that's less than 0. Now, one thing to think about here is that we can never reach infinity. So we'll write this with the parentheses and negative infinity, comma 0. Oh, and I made a mistake here. That should be less than or equal to 0. It looks like it's including 0. And my range since it's all real numbers, that means it's going to go from negative infinity to positive infinity. But remember, we can never actually touch infinity, so we're going to put those parentheses around there. Okay, let's look at a couple more. We've got this kind of V and this arrow like this, okay? Well, my graph goes from here and then just continues on indefinitely to the right. So my domain starts at -6 and then moves all the way to the right forever. So I could say that my domain is all the numbers that are equal to, greater than or equal to -6. And what about my range? Well, look at your range. Remember, it goes from up to down. So from here, here's my lowest point. Here's my highest point. Okay, what does that go to? Well, here I've got -3. And here I've got 7 up here if I count. Let's make sure. 1, 2, 3, 4, 5, 6, 7. Okay, so that means that -3 is less than or equal to x, which is less than or equal to 7. Okay, that just means all my range goes in between -3 and 7. Okay, let's write that with interval notation. Hopefully we're sort of getting the hang of it now. Well, because it's greater than or equal to 6 and that continues all the way to infinity, we include -6, but we can't include infinity, so we'll put a regular parentheses there. And our range, okay, we said goes from -3 to 7, and it includes those numbers. Just like that. All right, and then our last one here. I want to see if you can figure this one out. I'll challenge you and see if you can figure out what the domain and range of this linear equation or this linear graph is. Last thing I want to talk about is function notation. This is also a really quick section here. So here I have an equation, really a function. F of x equals 3x plus 4. So let's break that down. F is the name of the function. All the functions have a name. This function's name is f. The x, right here, this x, tells us what number to plug into the function. This entire thing here, f of x, that's how we read that, f of x. It means the output of the function f when the input is x, whatever number we put in. And then here, 3x plus 4, that's our function. Pause here to finish writing in that information. Okay, so let's illustrate finding f of 2 and f of -1 using the function machines we have below. Okay, so the way I like to think about functions is you put something in and then something comes out. Okay, think about it like if you're baking cookies. You put cookie dough in the oven and then cookies come out. So that's a function. Something's happening to the numbers that we're putting in here. So here we've got 2. Okay, I want to put 2 into my 3x plus 4 function. All I'm doing is swapping out x for 2. Figure out, okay, well, what's 3 times 2 plus 4? Don't need that parentheses there. 3 times 2 is 6, plus 4 is 10. So we can say that f of 2 equals 10. Okay, well, what about for -1? If I input -1, well, what's my output? We've got 3 times -1 plus 4. Keep writing that parentheses. -3 plus 4 equals 1. Okay, so I can say that f of -1 equals 1. Okay, so some new vocabulary here. A couple of examples down here I'll walk through with you, and I want to see if you can do some on your own, is let f of x equal x squared plus 3, and g of x equal x plus 1. Find the following values. So I've got 1 here, f of 3. Well, let's find f of 3. Well, my equation, or my function for my f function, is x squared plus 3. So I take that 3, I square it, and then I add 3. Well, 3 squared is 9, plus 3 gives me 12. Okay, if I wanted to use the g function, well, I've got here on question 2, g of 3. Well, what's g of 3? Well, g of 3 is just x plus 1, or 3 plus 1, which is 4. Okay, simple enough. What if we have an example where we're having to add two functions together? So down here on number 5, f of 2 plus g of 1. Well, we're just figuring out, well, what's f of 2? And then we're going to add that to g of 1. F of 2, it would be 2 squared plus 3, which is 4 plus 3, plus g of 1, which is 1 plus 1. So 4 plus 3 is 7, plus 2 gives me 9. Okay, so f of 2 plus g of 1 is 9. So basically all we're doing here is plugging in numbers. Just like we would evaluate an expression in the past, like in 6th and 7th grade, now we're just kind of changing it up and saying we're evaluating a function. Okay, one last I'll show with you, and then the rest I'll have you do on your own, is number 7, f of g of 2. Well, that sounds weird. What is f of g of 2? We're going to work from the inside out. So what is g of 2? Let's figure out the g of 2 part first. Well, g of 2 is going to be 2 plus 1, which is 3. And now we're just finding f of 3, which, lucky for us, we actually already figured that out in question 1. So f of 3 is 12. So f of g of 2 is 12. All right, so you're going to do the same thing for 8, and you're going to solve number 3, 4, 6, 8, and see if you can try that challenge.